Okay, fifth graders, so your homework tonight should be just like we were doing in class today. Feel free to use a calculator if you'd like. Don't know if you'll need it a whole lot. So cherry tomatoes cost $2.50 per pound, and then our rule, if it costs $2.50 per pound, we're going to multiply it by the number of pounds. So 250 times 1 is going to equal 250. Let's make sure we include a dollar sign since it's not written. And then on the next one, 3 times 250. It's going to equal 750, 7.5. This one we actually need to work backwards, so we're going to take 15. So on this one we'll take the 15 and we're going to divide it by, this time, 250. And we get 4. Let me try that again. That doesn't sound quite right. We'll do 15 divided by 250. And we get 6. That sounds way better. And then our next one, 10 times 250. We can just move our decimal over and we'll get 25 on that one. And again, we'll put our dollar sign in there just in case. And then we need to graph. Make sure you have a straight edge. I'm looking around. I don't have one right now. Oh, here's my straight edge. And the 0, 0 is our first point. And then at 1 we need 250. We got to figure out if we're counting over by ones or how we're counting. And then here's our cost, here's our weight. So it looks like 1, 2, 3, 4, 5. So we're counting over by ones and counting up 1, 2, 3, 4, 5, counting by ones today. So we'll go over to 1 pound. It's not indicated, but we can still find 1 pound right here. That's our 1. And we'll go up to 250. 1, 2, 250 is going to be between the two lines. Our next one is 3 pounds. We don't need to mark 2 pounds. 1 pound, 2 pound, 3 pounds. We're going to be on this line right here, and we're going to go up to 750. 5, 6, 750, so about right there. Next, we go all the way over to 6 pounds right here, and we're at 15. So we should be right on lines. And then our next one is 10 pounds, way over to the end, and we're going to go up to 25, so we'll be right there. We'll use our straight edge to connect our lines. And they should be nice and straight. Alright, so since we did this part, plot a point to show the cost of 8 pounds. 8 pounds. Here's 5, 6, 7, 8. If we go straight up, we can see 8 pounds. I lost it already. 6, 7, 8 pounds right here. Going across, looks like it's about 18, 19. Trying to find an exact on there. See if I'm doing it right. And it was 8 pounds going straight up. 5, 6, 7, 8. I need the ruler to help me find it. Oh, well that's better. It's right at 20. $20 according to that. Let's see. How would you use the graph, the rule, or the table to find out how much 50 pounds of cherry tomatoes would be? How would we use this graph? Since it only goes to 10, we could continue it out if we wanted to and do that all the way to 50. Or we could use this formula that we've already got up here. 250 times the number of pounds. So if it was 50 pounds, we could just multiply it by 250. That sounds a lot easier than using the graph. We could say, could extend the graph. You could also multiply 50 pounds by our formula up there, $2.50. And it says find out how much 50 pounds of cherry tomatoes would cost. So we have to actually solve this one. 250 times 50 pounds, 125. Let's see, you could also multiply 50 by 250 and it would equal 25. All right, moving on. Chantel is planning a trip to drive across the country. Her car uses 1 gallon of gasoline for every 24 miles. The rule, distance, for the distance, it equals 24 times the number of gallons. So if she puts 1 gallon in, she can expect to drive 24 miles without running out of gas. 4 here, so we can use that same formula. 4 times 24, if you need a calculator, equals 96. I'm off the screen here, but it equals, oh, it did before I bumped it. It equaled 96. Just going to fold this down here. We'll keep using our formula, but just move up a little bit. Now we've got 168, and we're going to go backwards because we have to figure out the gasoline. So if she went 168 miles and she gets 24 per mile, she must have gotten 7 gallons of gasoline on that one. And our last one, 13 times 24, 312. And then we're going to plot some points here. We'll start out with our 0, 0. She just doesn't have any gas. She's not going anywhere. And it looks like we're counting by ones again. Going up might be a little different. I'm looking and thinking it might be tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Yep, it looks like we're counting by tens. So 1 mile would be right here, first line. And she went 24. 10, 24, about right there. Next one, she went 4, she got 4 gallons, so there's 1, 2, 3, here's 1, 2, 3, I lost my spot already, 4, and that was 96, 10, 20, 30, well, I'm going to go start from 100 and work back. This would be 90, so 96 would be right about there. 7, 5, 6, 7, we're here on this line, and she went 168, so we'll do 100. 10, 20, 30, 40, 50, 68, so about right there. And next one is 13, 10, 11, 12, 13, we're right on this line. And if we go straight up, here's 200, there's 312, so we're going to go just a little past the 10 to get to 12. So about right there. These lines are very small. I hope that I have a straight line after all that. It looks pretty close. Plot a point to show the distance the car would travel on 6 gallons of gas. I lose my spot. I need to go straight up. If my lines are correct, it looks like I should have right about here. So let's see, 100, 10, 20, 30, 40, 50, about 150. And if I want to be specific, it would say 144. I'm going to write 150 because that's close and these lines are very small. But if you want the book answer, it's 144, and we need to put our unit in there as miles. All right, and would you use the bar graph, the rule, or the table to find out how far the car would travel? We could use that graph again to do that, or we could use our formula. When again we're trying to figure out which one would be easier to use and faster. If we continued that graph, it would be pretty big, and it would work, but again, there's some room for error. I think we would be better off using the formula. So let's say we would use a formula, or you could use (24 times 9 for our answer. And it equals 216. It is a bit more accurate faster. So now some might disagree on that one and might actually enjoy making that graph, but I think for me that's what I would say.